Welcome to Spring LIB.
We're given 4 sequences and we need to check that they satisfy the relation in green, an equal to -3 an minus 1 plus 4 an minus 2. So essentially every term is -3 times its previous term plus 4 times 2 previous terms. So the first sequence is an equals 0, so the constant sequence 0. Now we want to check whether 0, which is an, is equal, so we want to check if this is equal to -3 an minus 1 plus 4 an minus 2. But now we know that an minus 1 and an minus 2, we have an explicit description, so that's -3 times 0 plus 4 times 0, that's 0. And therefore we see that 0 is actually equal to 0, so the question mark is true. Similarly, if the sequence is given by the constant sequence 1, then we need to check whether 1, which is an, is equal to -3 an minus 1 plus 4 an minus 2. And again, this by the sequence that we're given is -3 times 1 plus 4 times 1, which is in fact 1. And therefore we've checked that 1 is equal to 1, or in other words, the question mark is satisfied. Now, if the sequence is given by -4 to the power of n, now the nth term is -4 to the power of n, and we want to check whether this equals the given relation -3 an minus 1 plus 4 an minus 2. Now, this formula on the right is equal to -3 that multiplies -4 to the power of n minus 1 plus 4 -4 to the power of n minus 2. Now, the trick here is to factor some part of this formula so that we can simplify things out. So we can write this as -3 minus 4 that multiplies -4m minus 2 plus 4 minus 4m minus 2, where we recognize that -4 to the n minus 1 is in fact equal to -4 to the n minus 2 multiplied by an additional -4, because in effect that's the definition of a power. But now we see that we have -4 and -2 that we can factor out. So let's write everything in brackets. We have -3 that multiplies -4 plus 4, everything collecting -4 and -2. Now inside the square brackets, there's just simple computation. That's 12 plus 4, so 16 that multiplies -4 and -2. But now we also recognize that 16 is in fact the square of 4, but also the square of -4. So the square bracket is -4 squared that multiplies -4 and -2. Now, by the properties of the powers, we know that the product of two powers with the same base is the same base power the sum of the exponents, which is exactly n. And therefore, we've checked that the question mark holds. Finally, if the sequence is given by twice -4 to the power of n plus 3, we basically need to check the same condition here. So I'll just start with writing -3n minus 1 plus 4 an, which is -3 2 minus 4n plus -1 plus 3 plus 4 2 minus 4n minus 2 plus 2 plus 3, sorry, and essentially we need to check that this is actually an. So similarly, it's a trick of recognizing -4 and -1 as a product. So the first bracket becomes 24 minus 4 n minus 2 minus 9, and the second bracket is 8 minus 4 n minus 2 plus 12. Okay, and now again we can collect -4 and -2. So this becomes 24 plus 8, which is 32. That collects -4 and -2. And then we have -9 plus 12, which is just plus 3. And now again, we recognize that 32 is twice 16. And 16 is the square of -1. So we write this as twice -4 squared where 32 is this is just a different expression for 32. Minus 4 n minus 2 plus 3. But now again, this becomes twice minus 4 to the power of n plus 3, which is in fact an. And so this is very